In this lesson, we're going to start with arithmetic, the familiar subject students learned since first grade. We will review the basic operations and generalize them into a bit abstract rules. You will see the rules are very simple, but these simple rules are fundamental, serving as building blocks toward more sophisticated math. In my view, to mature into algebra thinking, we must understand arithmetic, especially those rules, in a proper way. So what are those rules we are talking about? The first rule, or some people call it a property, is commutative. Property. Given two numbers a and b, we have a plus b equals b plus a. Okay, for example, simple enough, 4 plus 5, we know that we can add 5 plus 4. It's the same thing. And the commutative property also holds for multiplication as well. Or if I write as a rule, a times b equals b times a. Still, for the example of 4 and 5, we have 4 times 5 equals 5 times 4. You notice that I write the times as pretty small, really to distinguish from x. And actually later, you probably will see that it's more convenient write the multiplication as a dot. For example, equals 5 dot 4. Okay? All right, so for commutative property, you see that it applies to addition and multiplication. We know that the simple operation, there's also subtraction and division. Do commutative property apply to subtraction or division? The answer is no, or at least not directly. To see that, you see that 4 minus 5, it's not equal 5 minus 4. Or another 4 divided by 5, definitely not equal 5 divided by 4. And we're going to see that we can do a simple fix to subtraction and division. And commutative property is going to hold as well if with that fix. The second property for those simple arithmetic is called associative. As a simple rule, you write down, we have arbitrary number a, b, c. A plus b plus c. And of course that in the order of those operators, we're going to do a plus b first. So I'm going to use in parentheses to emphasize that fact. We do a plus b first, then plus c. This equals a plus b plus c. So this result is going to equal to if we do the b plus c first, then to add to a. And this also holds for multiplication. A times b times c. If we do a times b first, this is the same as a times b times c. So the fact of this is you can do the multiplication if they are neighboring. You can do in any order as you want. And of course that we can combine the associative property together with the commutative property, and then you basically see that the order of doing all those additions or multiplications does not really matter here, right? You can do, as long as it's all additions, you can do any order as you want. The same goes if you have just a bunch of numbers multiplied together, you can do any order as you want. And if that's the case, you probably want to do in an order that make things simple. And that's the idea for a lot of problems we're going to discuss today. So let's look at a few problems. But first, let's write down those two properties again. Commutative A plus B equals B plus A. Associative A plus B plus C, for the parentheses to emphasize that I'm doing A plus B first, equals A plus B plus C. This is true for any numbers A, B, C. Okay, let's look at problem number 1. Again, when I write down the problem, you're going to pause the video, think about how you're going to solve the question. And it usually takes 1 or 2 minutes, or as long as you wish. But if you get the answer, you can continue the video, or if you get really stuck, you should go on the video, and sometimes maybe you want to pause once you get a hint about the approach, and you're going to work out by yourself. That's, I think, the proper way of going through these lessons, especially on these problems. So problem number 1, calculate 128 plus 34 plus 66 plus 72. Okay, this is the time that you pause the video, try to solve this problem by yourself. And once you're ready, continue it. And of course, in this video, I'm continuing, assuming that you already finished your pausing. All right, for this problem, of course, this problem is a bit of artificially constructed. You see that for this addition, because of the commutative property, I'm going to change the order of adding. You look, 128 and 72, it's kind of so-called a pair number, because once you add them up, it becomes something very simple. In this case, it's 200. And for 34 and 66, you add them up, it becomes a 100, right? So the way to add, the simplest way to add, I should say, is you can add 128 plus 72 plus 34 plus 66. So it uses a combination of commutative property and associative property. Commutative, by moving 72 to front. Associative, I'm calculating 34 and 66 first, before I'm not adding 34 and then adding 66. I'm adding 34 and 60 together. So and this equals 200, the first parenthesis, and the second parenthesis is 100. So the whole thing equals 300. All right, that's problem number 1. Let's look at problem number 2. Calculate 1 plus 2 plus 3 plus 4 plus ... plus 100. Okay, so this is a well-known problem, and it's a problem probably you have encountered before already, and it has a very nice formula. But the basic idea to do this problem, at least one approach, is to pair the numbers together. you observe that in this sequence, if I change the order of the summation by using the commutative property, and then I associate it by comparing completing the pairs, 1 plus 100 equals 101. 2 plus the next number, 99, equals 101. And you see that you can pair this one by one. Every pair equals the sum of 101. Now the question is, how many pairs? And some students actually find it's a bit difficult here. The number of pairs. Well, if the number is even, you know that every number will be pairing together. So there are two ways to see number of pairs. The first way is think about what's the pair that the two numbers will meet each other. We know that the sum equals 101, so somewhere in the middle is 50. And you figure out the last pair you're going to add up is going to be 50 plus 51. That's 101, right? And now for each of the pair, if you look at the smaller number, the smaller number of each pair is go from 1, 2, all the way to 50. And that's kind of a sequence you're counting, right? So that means there are 50 pairs. Is that clear? So the sum equals 50 times 101 equals 5050. The second way of seeing the number of pairs is actually even simpler. You know there are 100 numbers, and each pair consists of two numbers. The total number of pair is going to be 100 divided by 2 equals 50. And again, the sum equals 50 times 101. Okay, I want to continue extend this problem to a little bit to look at a case when the number of numbers there is not even. Let's look at that case. So this is problem 2, but a little bit extent. How about 1 plus 2 plus all the way to 99? So you see that it's not all the numbers going to be paired together, even though that each pair is going to be 100. Very, very nice. Because this is odd number of terms in this sum, there will be one term remaining. And what's the term remaining? The term remaining will be the 100 divided by 2, the middle term, somewhere in the middle, right? And that term is going to be 100 divided by 2 term. Because for that, to make the two term add up to be 100, if the two terms are the same, then you know that these two numbers do not coexist there, because all the numbers here is 1, 2, all the way to 99. So this, you can think about there are 49 pairs of 100, and plus that term in the middle, that is 50. So this equals 4950. Okay? But another way I personally much prefer is the way of just reversing the order. Instead of, you have to worry about its even terms or odd terms. I'm going to write down S, which is sum, equals 1 plus 2 plus all the way to 99. And now I'm going to reverse the order of doing the sum. S also equals 99 plus 98 plus all the way to 2 and to 1. Okay? The S is the same because of the commutative property, right? Now, I'm adding those two things together. I'm calling 2S because I'm just taking this whole thing, adding this whole thing. Okay? Equals 1 plus 2 plus 99, in between, plus 99 plus 98 plus 1. All right? And that, I'm using the commutative property and the associative property equals 1 plus 99 because I'm moving the 99 to the second term. And then plus 2 plus 98, the 98 goes to the fourth term. And all the way to 99 plus 1, which is basically the last two terms add up. And this equals 100 times, because each parentheses add up to be 100. Nice. But how many terms? Okay, in terms of how many terms, again, you look at each pair. The first number in this sum is 1, 2, all the way to 99. So there are 99 terms. So this equals 9900. So the S equals, because 2S equals 9900, S equals 9900 divided by 2 equals 4950. All right, and this kind of gets rid of the little problem of when the terms is even or odd. And in general, I'm going to write down the general form of doing 1 plus 2 plus all the way to n. And this equals n plus 1 times n divided by 2. And this factor, of course, is not expected for students in 3rd or 4th grade. But to get this formula, it uses nothing but this reverse order of adding and then applying commutative and associative property. Okay, let's look at problem number 3. And this problem uses commutative property and associative property for numbers not integer anymore. These are decimal numbers. 0.28 plus 0.34 plus 0.66 plus 0.72. It's time for you to pause and look at whether you can solve it by yourself. And of course, this problem is very similar to problem 1. The only thing I'm adding is have a decimal point. But the fact is, again, the same, that you recognize that these two numbers is kind of a pair. These two numbers is a pair. And you're going to add them together first and add the other two first. So equal 0.28 plus 0.72 and plus 0.34 plus 0.66. Okay, 1 plus 1 equals 2. Of course, that if you look at the first problem, problem 3, initially, if you're just adding according to the order that the problem is giving to you, it might be a little bit complicated, tedious, and it's very easy to make some mistakes here. But if you know that, you realize that you can adding according to this, pairing, it's going to be very difficult to make an error. Actually, you see that the creator of the problem is actually asking you this, and I mean, there's really no reason of making an error if you recognize this fact. Okay, now let's look at for additions. We already looked at for additions. Let's look at these two properties for multiplications. And the idea is completely analogous. So problem 4. Calculate 2 times 125 times 5 times 8. All right? Try it yourself first. And if you're coming back, you know that You recognize 2 times 5 is 10. 125 times 8 is 1000. So this is going to be equal to 2 times 5 times 125 times 8 and equals 10 times 1000 equal 10,000. Simple enough, right? And it uses commutative. I'm moving the order first, and then I use associative. Problem number 5. How about I calculate 2 times 2 times 2 and times 2 times 25 times 25. All right, this problem is actually very simple to the first problem, except you don't see directly the pairing. Well, actually, you can see the pairing. I mean, you can just pair 2 times 25. It's simple enough, 2 times 25. But the idea actually originally when I put this problem is I want you to see that 25 is equals 5 times 5, 25 equals 5 times 5. So the whole thing is actually 2 times 2 times 2 times 2 times 5 times 5 times 5 times 5. And then you see that I want to do 2 times 5 first, and there are 4 such things. So equal 10 times 10 times 10 times 10 equal 10. The same as the first problem. So as I mentioned, the commutative property does not apply to subtraction. And we use the example 5 minus 4 not equal 4 minus 5. Okay, but there's a simple fix. And the fix is really treating subtraction as a addition, but adding a negative number. So we treat 5 minus 4 as 5 plus negative 4. Okay, think of for a moment, what is negative 4? Negative 4, one way to think about it is on a number line. You have a 4, so I put the 0 point, and then somewhere there's a 4, right? 1, 2, 3, 4. Okay, it's not equally spaced, but for a moment you think about this is 1, 2, 3, 4, 5, and go on. The negative 4 is really the symmetric point of 4 relative to the 0. So you just measure this and you put here. And this is negative 4. So this property of this negative 4 is really defined as a number that negative 4 plus 4 is 0, or negative 4 is the mirror of 4. In that case, you also kind of understand that you need to see this negative 4, negative of negative 4. It basically, the mirror image of a negative 4, it basically goes back to 4 equals 4. Okay, intuitive? Okay, with this negative 4, we can write down the subtraction 5 minus 4 equals 5 plus negative 4. And now, this is a number, adding another number, and this is commutative. So this equals negative 4 plus 5. Okay, with this, it's commutative. And similarly, it's going to be associative as well. So 5 minus 4 minus 3, for example, you write down as 5 plus negative 4 plus negative 3, and this equals 5 plus negative 4 plus negative 3, and this is the same as 5 plus negative 4, negative 3. All right, and this equals, of course, 5 minus 4, negative 3. So in here, associative also works. And this is a small fix for subtraction. For division, it actually goes Similarly, let's look at how we fix the division. We know that 5 divided by 4 is not equal 4 divided by 5. In here, we're introducing the reciprocal 4. 5 divided by 4 it actually equals 5 times 1 over 4. And now it's two numbers multiplied together, and this equals 1 over 4 times 5. Similarly, if I'm having 5 divided by 4 divided by 3, this equals 5 times 1 over 4 times 1 over 3, and this equals 5 times 1 over 4 times 1 over 3. So the trick of changing division to multiplication is introducing this 1 over 4, 1 over something, and that is called a reciprocal. And we're going to write down, if you have x, the reciprocal of x is 1 over x. Now for x is integer, let's say 10. Of course 1 over 10, 1 over x equals 1 over 10. Easy, right? But how about x itself is 1 over 10? Then the reciprocal of 1 over x is basically changing the denominator and numerator. Swap them. So this goes up and this goes down. It's 10 over 1. And x is a fraction. That's perfect. 1 over x equals, swap them, 7 over 3. Okay, so we're basically doing a lot of reviewing. But the important fact for division is you changing into multiplication of reciprocals. And then commutative and associative properties still hold. So now let's look at a few problems involving division and subtractions. Problem 6. What is 2 plus 4 plus 6 plus all the way to 200 minus 1 plus 3 plus all the way to 199? Okay, I'm putting parentheses so that it's you see it as two terms. Time for you to stop and think how you are going to solve it. And I'm telling you there are quite several ways to do it. Okay, so to think about it, there are two ways I can think. One is you really can calculate this directly. In fact, for this, 2 plus 4 plus 6 plus all the way to 200 is really very similar to 1 plus 2 plus 3 plus 100, except every number is doubled, right? So you can calculate this and multiply 2. Or you think about using the same technique as calculating 1 plus 2 plus 200, you pair them together. All right, that's one way to calculate it. Similarly for this. This is also very similar to 1 plus 2 to 100 in terms of technique. You pair them together. Another way of calculating, that's one way. Another way of calculating, which is the way that I want to emphasize here, is you notice that when you have a minus here, but if you're treating those minus as plus of negative numbers, then you can apply the commutative and associative rules. And then you realize that 2 plus minus 1 is 1. 4 plus minus 3 is also 1. And you basically can compare them together, and each pair is going to be 1. 200 minus 199 is going to be 1. So the whole thing is really equal to 2 minus 1 plus 4 minus 3 plus 200 minus 199. Okay, you will see that a lot of mathematical questions that in my lectures really depends on your observation. You're going to see the patterns. You see that something strange about the problem, and that strangeness might be able to help you. Okay, continue for this problem. 2 minus 1 is 1, another 1, another 1. Now the question is, how many ones? All right, so for that, you realize that for each of the pair, the first number is an even number, and the even numbers goes from 2, 4, all the way to 100. How many even numbers there are? One way to think about is totally from 1 to 200, there are 200 numbers. And in these 200 numbers, there are equal number of even number and odd number, which means there are 100 even number and 100 odd number. Why they are even equal number of even number and odd number? Because they're alternating. Even, odd, odd, even, even, odd. Actually, odd, even, odd, even, odd, even. Always alternating. So there's 100 numbers there are. So it's basically equal 100 terms equals 100. The next question is very similar. And I'm going to write down. I'm going to just say it very, very briefly. And I believe this is a MOMS question, Math Olympiad for middle school and elementary school competition. Of course, this is a simple problem for that. 25 plus 35. And again, you realize is each term, the difference is a 5. Because I'm minus, so it's 5 times 4 equal 20. Okay. The next two questions, actually next question is about division. And the question goes 10 times 20 times 30 times 40 divided by, and divide, of course, you can using this written this way, 5 times 10 times 15 times 20. Okay, pause for a moment to see if you can figure out very quickly. And of course, the way to solve it is you write down as division as a multiplication of reciprocals. So it's equal to 10 times 20 times 30 times 40 times 1 over 5 times 1 over 10 times 1 over 15 times 1 over 20. And now you realize that this is, you can pair them together, pair them together, pair them together, pair them together. By using the commutative law and associative law, you get 2 times 2 times 2 times 2 equals 8. Okay, I'm skipping one step. I'm really write down as 10 times 1 over 5 times 20 times 1 over 10 times 30 times 1 over 15 times 40 times 1 over 20. Okay, and each one equal to 2. So we have talked about commutative and associative law. Now there's a further law, is kind of combining the addition and multiplication together. And this law is probably the most powerful law here, and it's called distributive law. It goes like A plus B times C equals A times C plus B times C. And why it's called distributive? It's really you are multiplying A plus B times C, and you're distributing C into each of the terms inside parentheses. So A times C and plus B times C. Now we kind of know this law in one direction. If you look at A times C plus B times C, this equals A plus B times C. By knowing this, let's just think about this very simple case that I often use. If I have 7 apples, you have 3 apples. Totally, how many apples do we have? 7 apples plus 3 apples equals 10 apples. And in here, we're really using the distributive law because this thing equals 7 plus 3 times apples. And this step of 7 apples plus 3 apples equals 7 plus 3 apples equals 10 apples. This step of taking out these apples, which are of course in here, the units, is called pull out the factors. And this corresponds in this distributive law, correspond the direction from the right to the left. You will see that it's equally important of going from the left to the right. And which step is called the distributive. This step is actually pulling out the factor, or simply factoring. Let's look at a few examples, and you will quickly see that the simple rule, this distributive law rule, is very, very powerful. Okay, let's look at problem number 9. Calculate 21 times 52 plus 21 times 48. Okay, pause for a few seconds to see if you can solve it by yourself quickly. All right, this applying the distributive law, you realize that the 21 is a common factor in the two terms, which is multiplying. And this you can pull the factor 21. So this equals 21 times 52 plus 48. To verify that you're doing the right thing is you just look at it, 21 multiplied by the summation of these things. If I'm going to distribute it back, I'm going to do 21 times 52 and 21 times 48, and look at it, it's the same as the first form. So they're the same. And now you realize 52 plus 48 equals 100, so this one equals 21 times 100, and this equals 2100, right? Of course, the numbers are constructed, so you have a simple answer. And that's the beauty of those kind of problems. Once you get this, you know that your answer must be right. Okay, problem number 10. Just a little bit more involved to illustrate the point that the distributive law also works when you have more terms. Okay, just think for a moment. We know the distributive law equals in the form of C A plus B equals CA plus CB, right? How about if we're adding one more term? Let's say plus a D. Of course, that does not really matter. You can just see 2D. All right? It's very simple. Adding any many terms is still going to be distributed back each term into every term inside the parentheses. So, and that's, of course, it's true that from this side, the right side to the left side, which is the factoring side, as long as you have a common factor, you can pull the common factor out. So for this problem, equal 21, which is a common factor, times 34 plus 34 plus 32. Now you hear this thing constructed to be added up to 100. So again, equal to 100. Okay. Let's look at problem 11. And this involves a multiplication. Looks a bit of complicated. And I try to use this to illustrate the point that the distributive law also can be used on the other direction. Because 999 is really equals 1000 minus 1 times 678. Using distributive law, this equals 1000 times 678 minus 678. And 1 times, right? Just want to illustrate a point. You distributed this common term into every term inside parentheses. So this equals 678,000 minus 678. And this subtraction is relatively simple. 677, 3, 2, 2. All right, so the distributive law can actually go both ways. And the last question, of course, is the most difficult one. It involves several steps. 34 times 54 plus 54 times 21 and plus 53 times 46. You look at it, you see the first two terms has a common factor and the last one does not. What's going on here? Well, when you see the common factor for the first two terms, let's just try to pull that factor out first. So it's 54 times 34 plus 21 plus 53 times 46. Oh, now I see, because 34 plus 21 is 55. Okay, I write down the problem. Oh, I wrote down. Wrote down wrong. 32 times 34 and plus 54 times 21. So it's 32. I constructed the problem correctly. For a moment, I thought I did the problem wrong. So you see that 32 plus 21 is equal 53. And here is a 53. So I can do the factoring again. And that's where the problem is really heading for. And this equals 53 times 54 plus 46. And aha, this is 100, so we know that is 5300. Okay, so this is applying the distributive law twice to get this problem. And this is the end of this lecture.